Let's go ahead and get started with implicit differentiation. Last time we looked at explicit functions. That's where you see something like y equals f of x. So y equals sine of x, for instance, is an explicit formula of x, or y equals x squared plus 1 to the fourth is an explicit formula of x, because if you know x, you can just plug it in, and it will give you one and only one y value. There's no ambiguity here. If you look at the graph of an explicit function, the graph of a function has to pass the vertical line test. So when you draw a vertical line, you get at most one place that the vertical line hits that curve for any value of x. Now notice I said at most one, because it would be totally valid for this to be undefined. You could totally have a graph that looks like this. Maybe you have a vertical asymptote at x equals 1. And in that case, if you draw your vertical line at x equals 1, it doesn't hit at all. It can hit 0 times or 1 time. It just can't hit twice. Implicit functions don't have this property. There may be a situation where you don't have this y on the left-hand side and x on the right-hand side. Instead, you might see something instead like the equation of an ellipse. So for instance, you have an ellipse here. You could have 2x squared plus 3y squared is equal to 1. And this gives some relationship between x and y, but it doesn't give the kind of relationship where you can just tell me the x value and plug it in and evaluate and get the y easily right away. Another example would be something like x times y is equal to 1. So if I have x times y is equal to 1, I can't just say immediately that there's y on the left-hand side and x on the right-hand side. And so for these graphs, when you see a graph of an implicit function, it might not pass the vertical line test. And in fact, technically, this is not actually a function. It shouldn't actually be called a function, but we still do. And I'll explain why in a minute. But when you see the graph of an implicit function, it could be as gnarly as you want it to be. Like this could be the graph of an implicit function. Or this could be the graph of an implicit function with all these pieces. Or this could be the graph of an. So anything you want to draw, you can say, hey, this is the graph of an implicit function, and you're good to go. You do not have to worry about the vertical line test when you're dealing with implicit functions. So any curve you draw in the xy plane, you could think of as an implicit function.